So today we'll conclude UDP with a complete example. Let's take this problem statement. The problem statement is that a client machine sends a request to a media server. Media server means a server which serves audio, videos. The name of the server is given, and that particular server is listening on port 1755. The IP address of the client as well as the media server is given. The server receives the request, and before sending the file, whatever file it requested, it sends a hello client IP message to the client. Now there are certain values which are given. Assume that the lower layers, the network layer and data link layer, adds 24 bytes of header. The MTU, or the maximum transmission unit, given is 40 bytes. All communication happens over UDP. You are supposed to show the UDP segment or segments if more than one segment is necessary for the hello client IP message sent from the media server. You are asked to assume any information that is required. Now ponder for a moment and try to understand what the problem is. So let's try to visualize the problem. So we have this client machine, this particular client machine, which is requesting for a video clip from this media server. The media server is listening on port number 1755. The IP address of the client is given, the IP address of the server is given. So the client sends a request for a video file. The client will first send a hello message, hello client IP message. So the message that will come first will be a hello 105.25. This message will come from the server to the client, and after sending this message, the server will start sending the video file. Now the problem is specified is to find the and show the UDP segment or segments for this particular message, hello client IP message. Now first let's see what informations are given and what information we are supposed to assume. The client IP address and the destination IP address both are given. The server port number is given. If you remember the UDP segment structure, we require a source port, a destination port, and then we require the checksum, and also we require the length. So length and checksum we obviously have to calculate. Because only the server port is given, we require the client port as well. So the first thing we'll have to assume is the client port number. So let's assume the client port number to be any value, say 7000. The next most important part which we have to decide is whether we can send the complete message in one UDP segment or we require more than one UDP segment. Now let's see. The UDP header, if you remember the UDP segment correctly, the UDP header size is fixed to be of 8 bytes. The the information provided in the problem says that the underlying network layer and the data link layer add 24 bytes of data. So we have already 32 bytes of header information. The data, the actual data that is to be transmitted is hello IP address. Hello is 5 bytes. I have a space here. So we have 6 bytes here, so 6 bytes, that makes hello the space, and the IP address is of 4 bytes. This makes total 10 bytes. So if I add all this, 24 plus 8, 32, 32 plus 10, 42 bytes. So 42 bytes of information is to be sent from the server to the client. But the MTU given is only 40 bytes. That means the actual frame that will be transmitted by the data link layer, it can be of maximum 40 bytes of size, whereas the total information I have is of 42 bytes. So this explicitly says that we require at least 2 UDP segments. Why do we require 2 UDP segments? Because we have 42 bytes of information, but the MTU is of 40 bytes. So we have to divide this data into 2 UDP segments. So let's visualize the 2 UDP segments that we are supposed to send. So this is the first UDP segment and this is the second UDP segment. So both would have the header part, source port, destination port, length and checksum. length and checksum would be different obviously for these two different UDP segments, because this UDP segment will send certain amount of information, this UDP segment will send certain amount of information. Because this header part is fixed to be of 8 bytes, and if you make the calculation correctly, we have 8 bytes here, there are other 24 bytes to be added by the underlying layer. So 24 plus 8, 32. Because the maximum transmission unit is 40 bytes, so I can add only 8 bytes of information in this. So we'll put hello and 2 parts of the IP address, that makes 5, 6, 7, 8 bytes here. So 8 plus 8, so 8 bytes here and 8 bytes here. The total length of this UDP segment would be of 16 bytes, and again 8 bytes of header information here, and another the remaining 2 bytes of information would be inserting in this particular UDP segment. So for the first UDP segment, the source port would be 1755. This should be obvious. Remember, if we had to find the UDP segment for a message from the client to the server, then the source port would have been the source port of the client machine. But now, because the message is coming from the server to the client, that's why the source port would be of the port of the server. So this is already given as 1755. We have assumed the client port to be 7000, so the destination port would contain the value of 7000. The length of the first UDP segment is 16 bytes, which we have seen in the previous slide. 16 bytes is 8 bytes of header information and another 8 bytes of actual data. We have to calculate the checksum. For the second UDP segment, again the source port would be same, the destination port would be same, the length would be 10 bytes, 8 bytes of header and 2 bytes of information. We have to again calculate the checksum for this second UDP segment. So I am showing the values for the first UDP segment. For this second UDP segment, you do it in a similar fashion. So for the first UDP segment, the source port value 1755, this is converted into 16-bit equivalent binary. This you have to actually calculate. So the 16-bit binary equivalent on 755 is calculated. Similar for the destination port 7000, this is a 16-bit binary equivalent. The length is 16 bytes. This first segment size is 16 byte. So this is again the 16-bit binary equivalent of 16 bytes. Remember, for the second UDP segment, this has a separate value. The length is 10 bytes for the second UDP segment. So this value change for the second UDP segment. The checksum you have to actually calculate. Calculation of checksum was discussed extensively in the previous lecture. Remember, to calculate checksum, you have to also use the source IP address and the destination IP address. So please refer to the previous lecture and calculate this checksum yourself. This is a part of your homework. And this first UDP segment will contain this data part hello space and the first 2 bytes of the IP address. So this has been again converted into binary. 1 byte each for HELLO and the space, and again 1 byte each for 105. So this all has been combined into this this binary format. So this is the first UDP segment. In a similar fashion, you calculate the values. You have to actually calculate the checksum, and the data part would be the remaining 2 bytes of the IP address. So for the second UDP segment, the length value will change, the checksum value will change, and the data value will change. So with this, we have concluded UDP. We have concluded the third unit. From next lecture, we start with TCP, or Transmission Control Protocol, the reliable data delivery protocol of transport layer. Thank you.